All right, you guys all ready to begin? Fantastic. Welcome. So we will be talking about development and .NET applications today on the AWS platform. Hopefully that's what you're interested in. We'll look a bit at using Microsoft SQL Server as well, since most .NET app developers program against SQL Server. And so we'll look at RDS and some of the managed database aspects. So I'm Brian Lewis, and let's get started. First, let's talk about market opportunity. This is a partner presentation, so I did want to talk a little bit about the opportunities for partners. And the fact is, if we look at .NET applications and Windows workloads in general, the aspect of enterprise workloads in the Fortune 1000, it's around 80% of applications are C# .NET applications, some Visual Basic .NET as well. But the majority of the applications are Windows workloads in those environments, and the .NET is the biggest piece of that. So it makes a lot of sense then to look at what we do as we start to close down data centers. As we close those down and move things into the AWS environment or others, how do we do that? What's different about public cloud versus doing it on premises? So look at that. And if we look at why customers want to move, there's all kinds of reasons. We just did a survey, and one of the things that I was interested in is number 8 in the list of the survey we just did was about cost. So customers don't care as much about the fact that it's cheaper to do it in the hyperscale AWS large cloud environment, as they care more about agility. And if you think about other aspects of what can happen there, this story always gets me and kind of solidifies for me one of the great things about public cloud. If we go back in memory to 2001, 2002 timeframe, there was a toy company about this time of year did a big push for Black Friday and to try to buy stuff online. And many of us buy stuff online today, but back in the early 2000s, we didn't. Most of us didn't. So they did this big push, big advertising push. As a matter of fact, if anybody remembers this, if you spent over $100, you got a free Tickle Me Elmo doll, and who can't resist that, and free shipping. So that drove people to go to the web. They had built their environment out to handle 2.5 times the volume that they've ever received to the website. Unfortunately, or fortunately, I don't know how you look at it, their marketing group drove 10 times as many people as they'd ever had before to their website. So what do you think happened?
Lots of cranky kids at Christmas.
Crash. Lots of cranky kids at Christmas. That's pretty good. Lots of cranky kids in the boardroom. The site was down, and it was down for 2 weeks. Basically, it was continually denial of service by customers coming and trying to get their free Tickle Me Elmo doll. So what they did to fix it is they added 200 servers, which did fix the problem. However, back in the early 2000s, how long did it take to add 200 servers to your front end of your web app, of your web store? It was 2 weeks for them, but that's crazy amazing good, right? That wouldn't take most people 2 weeks. That would take most people months to add that. They were working tightly with their supplier and partner, and they were able to get that running in 2 weeks, 200 servers, fantastic turnaround time, cost them millions of lost sales, millions of dollars. But if you think about that, how long does that take today? For example, in AWS, if you were to add 100 servers, how long would that take? About 4 minutes. That's a huge, huge difference, right? And so that is really, to me, what what the AWS environment, what that offers is that ability to really take advantage of 1,000 servers that are sitting there, of tens of thousands of servers that are sitting there, and spin that up. And then when I don't want to use them, when the sales go away, right, because Christmas time is only right now, and in a couple of months, there won't be near as many people hitting, especially stop your Tickle Me Elmo sale. Then you don't need to keep expensing and paying for those servers. You can release them. And that's some of the aspect that we really get out of this environment. There's other things too, right? The ability to, when a product team says, at the company says, boy, whether it's HR or some other group, I want to put up a server. That whole aspect of acquiring servers and making that available to them is a much faster process. So that's really what we get out of this type of environment. When we look at AWS, what we're going to look at is the RDS database, and we're going to look specifically at managed services. So I've been an infrastructure guy my whole life, and I am sloppy at code, right? I don't do try catches. I cut and paste code and just make it work, and if I get it to work, I'm really happy. So I'm not a professional programmer, but I have done a fair amount of programming, and I'm the infrastructure guy. But most of my programmer friends are not the infrastructure guy. They code really well, but they don't know a lot about TCP/IP, about subnets, about building infrastructure out. And what's really neat is with these automated services, they don't need to. When it's managed by AWS, they can say create, and they get that. So let's go through a little bit. I'll talk a little bit about the infrastructure behind it that gets built, but the developers don't need to know it as much. And we'll start with SQL Server. So there's two ways to run Microsoft SQL Server in our environment. One is managed by us, and that's called RDS. And then when you run RDS, you choose Microsoft SQL Server, or you can choose one of several other databases. The other way is to run it on top of an instance, which is running it on top of a VM. Now that offers more choices than you're going to get in RDS. I can use much larger instances. I can use the instance up to 4 terabytes of RAM. I can use things such as multiple EBS volumes going there, so I can span across multiple LUNs, basically. I can do other types of things and get access to more disk than I can do inside my managed RDS environment. But those are for extreme cases. Most of the time, the databases aren't that big, and I mean, you can still get up to terabytes, right? Or I'm not exactly sure the 16 terabyte of storage. So I can get up to 16 terabytes in the managed. I can get 26 times that in the instance size. They say 400 terabytes on the slide, but we support up to 26 EBS 16 terabyte connections to it. So anyway, these are the two types that you can look at. If we look at the comparison of them, the difference in managed versus unmanaged and what you have to do is a ton. So for example, when I set it up myself on the right side, where I manage the SQL boxes, I do the work, I have to patch the OS, I have to do all of the install. So I take the application and I install the application, I manage that, I have to go set up, if I want replication to go, I have to set that up. If I want backups to happen, I have to set that up. I have to do all the work. If I'm using the managed environment, once that is set up and you run through the wizard to set that up, we take care of all the things. We take care of patching the operating system. We take care of the patching of the database itself. We take care of backups. And you do select how long you want us to store those backups, but we'll take care of taking the backups. The aspect of high availability, that's done by us as well. I'll talk more about this in a minute, but we'll go in 2 separate availability zones, and hopefully you understand the availability zone concept. So we've got 2 separate data centers that are in different floodplains, and we've got 2 databases running doing synchronous replication because we have under 2 millisecond response times between those data centers. And so with that, if I have one of those servers fail, we fail and start reading from the other data center and the other server, we will automatically tear down that server and create you a brand new server and start synchronizing the data back to that. So we'll replace that bad server. And that's when you're in multi-AZ, you can also add more databases as well that will synchronize. We're also using database mirroring there. And that high availability is all taken care of without you having to set it all up and work at it, which on the instance side, you'd have to do the work. So if we look at this automatic failover, the synchronization that happens is synchronous, which means that when I do my application goes and it commits data, it puts it to both database servers. It has to hear back, basically, from both database servers before it moves on. And why that's important is because it would be a bad user experience if I had to wait too long. So if that was a normal data center environment, which is usually 30, 50 milliseconds that it takes to go send a packet across, round trip, I'm waiting, 60 to 100 milliseconds for that commit. That would be a bad experience. So people don't do synchronous communication. They do what's called asynchronous, which is they send the data and then they move on and hope that it gets there. So the problem with that is that if there is an outage, there's some data that will be lost. It's a minimal amount because it's whatever's been sent and not committed to disk, but that could be lost. And when you ask your business groups, well, how much data can you lose and how long does it take before we get back up and running again? What's acceptable? If you ask them just straight out, they say, well, I can lose 0 data and I need to be up and running immediately. And then you give them the bill for that and they say, well, what are the options? As that's generally too expensive. If you're running something that really requires that and you want to spend that money, you would traditionally set up 2 servers in a data center in different racks that would do the synchronous communication, and then in a remote data center, you would set up another server and you do asynchronous. So that takes 3 servers, and then if you do have a flood or some type of failure at the data center and you fail over to the other data center, you have some data loss. And if you don't do that, you just do shipping of your backup tapes, maybe it'll take you a week to get back up and running. And for some apps, that's okay, and for some, it's not. In this environment, it's a very low cost that I can have the best of both worlds. I can have downtime and 0 data loss. And I'm only running 2 servers. So that's 2 servers that I pay for versus 3. That's 2 licenses versus 3 kind of stuff. It's a really nice environment for that. The other thing is we're using database mirroring here. Now, if anybody's read the Microsoft web pages, database mirroring is deprecated, and they recommend using high availability. So SQL Server high availability is an enterprise feature. It actually was just added to standard in SQL 2017, but previously it's been an enterprise-only feature. We're using mirroring, and so therefore it's in standard, it's in enterprise, it's even in web and other editions. So we can do this multi-AZ approach without having to use enterprise. So that's one of the nice things about mirroring. The other thing is we're doing the watching and the switching and the rebuilding and all that work for you, which you would generally need enterprise and clustering and that kind of stuff to get that to work. So if you're going to do it on the instance, you'd have to set those things up. So this RDS is kind of a neat thing and kind of nice. You don't have to do it in a multi-AZ environment. You could do it with just 1 server. And for development, you might. Why would you want to do it with just 1 server? It costs less. You're only paying for 1 server. If I'm doing it with the 2 servers, I'm doing 2 servers, and I've got a load balancer that I'm paying for. It's a bit more expensive, but it's also a bit more enterprise-worthy, at least gives you high availability and all that stuff. So it's definitely your choice, and it may make sense in some environments to use a single server, and in others to use 2 or add more servers to the mix. So you can certainly add more servers in that environment too. So if we do it in an instance, it's recommended you use SQL Server, always-on availability groups. You use Microsoft clustering, but the clustering isn't using the shared storage clustering. It's just using the clustering pieces that wrap around it to watch for failures, to say, hey, wait a minute, that's failed, and let's go and move the workload to another server. There are some other benefits you get in multi-AZ, always-on availability groups as well. For example, the other copy that's sitting there is a readable copy. So as my people are updating the database and working in the application during the middle of the day, and I want to run some reports, but say I don't want to affect their performance, I can run it against the read-only copy. So that is a nice feature that always-on availability groups gives that database mirroring does not support. So there may be reasons that you would run this instead. So those are the 2 ways, and if we look at that in a standard type of environment for a corporate setup, every company is probably different, but this is what I see most often, is that we've got the SQL Server, we've got the applications in separate AZs, those are separate subnets, and this gives a high availability aspect. The other thing is we have a VPN or a direct connect coming from the traditional on-premises, the corporate LAN, and we kind of treat the AWS network as just a remote data center. And so in the Microsoft space especially, we don't do much different than we do for any other remote data center. You put Active Directory out there, you extend your Active Directory. Now for RDS, you can't join an RDS server to your traditional Active Directory. The reason for that is you don't get to manage and be admin on the RDS server. AWS is, and we're doing the patching and managing it for you. And if you were to remote into it, you could break all the stuff we're doing. So we don't let you into it. We're controlling it. You get access to the database engine. Now, there's some apps that won't work with that, so there are some things that it doesn't fit for. But the other thing is, if you were able to join it to your Active Directory forest, well, when you're domain admin, you can pretty much do anything on a server. And so you can't do that. What we do is, if you need to use Active Directory integrated authentication to your database, what you would do is you would set up a managed AD environment, where we're managing the AD environment, and then if you have a bunch of users in your traditional corporate environment, you would trust from the managed AD, you would trust the corporate AD, and that would give your users, because that one's trusting the corporate one, that would give your users on corporate the ability to access resources that you've given them rights to in there, which the Microsoft SQL Server could be part of. With a one-way trust that way, things you create in your managed AD would not be able to access your on-premises environment. Now, if you did a two-way trust, then you could set it and go both ways, and that's fine too. But you would trust from the managed AD, and you would trust the one where all your users reside. Is how that direction works. Anyway, this is the standard setup. To remotely manage servers, you can come into the public subnet if you want and use a RD gateway and jump. But if you're already coming in from the corporate LAN, you'd probably not do that. You'd probably have that firewalled, and you would just come in from the corporate environment. You VPN into corp, and then you just treat it as you do all your other data center servers. All right. Before we move on, what I want to do is switch over and just take a look at what it takes to set these things. So let's switch over to my workstation. And here in my workstation here, I'm logged in to my AWS account. And under databases, there's RDS. So I'll go to RDS. In the RDS space, I have some instances. I have some databases already running. But let's launch another one. I have two up and running. So I can launch Aurora, I can launch MySQL, MariaDB, Postgres, Oracle, or Microsoft SQL. And we're going to watch Microsoft SQL. Now when I choose that, I can choose Express, Web Edition, Standard, Enterprise. I'm just going to choose Standard. I'll hit Next on that.
Are those databases multi-tenant, or are they other people's databases on the same server?
So the question is, are these databases multi-tenant? The databases are single tenant. The OS that it runs on is multi-tenant.
Okay, so dedicated engine per customer.
Right, this is a dedicated engine for the customer. It's a dedicated OS instance for the customer. But that instance, we may have Coke running next to Pepsi on the same server.
Oh, okay,
At the hypervisor level.
It's a dedicated SQL server for that account.
Right, it's a dedicated SQL server, and virtual machine is dedicated.
You can add as many databases as you can scale up to.
That's correct. You can add as many there as you can scale up to. Sure. Yes, it is. Thank you. So I can do license included or unincluded here, right? And license included means I'm going to pay an hourly charge that includes the license to that. I can choose my engine. So do I want to use SQL Server 2016, 2017, go down to 2012, 2008. We'll just take a 2016 engine here. I can choose the size. Now, in this area, I have less choices of instance sizes than I do if I was to choose my own instance. So I can't do like a T2 micro, for example, here. I've got my 2 vCPU, 8 gig of RAM is my small one, and I can go up to 64 vCPUs and 488 gig of RAM. We'll choose a 2 CPU, 8 gig. I can set the time zone, and here's the spot where I can say, do I want multi-AZ deployment? And so this is the big deal. This little radial button is a difference between running a single, server or running a multi-server environment. And so in this environment, we'll set up mirroring and do multi-server. I can also choose my disk. If I'm doing an enterprise type deployment, provisioned IOPS makes sense. It gives me a faster disk. I can also do standard SSDs or general purpose SSDs. And I can set the size of my database. Now previously, of my database, if I was to want to change the size of my database, I would have to create a new one and then migrate my data. And customers stated that that was less than interesting or optimal for them. So we added a new feature now where I can go in and change the size of that database. And while it's up and running, the database beneath it will change in size. While it's changing and while it's making those changes beneath it, you can't make any more changes to the size. But then once it's done, you can change the size again. All right, let's go take a look at this and set something unique here. And I'll give it a name and password for the SA account.
The magic button is going to create another database server exactly the same for the very another AZ in another.
Well, so what I just did is I set up and just told it what pieces I wanted, and that radial button said set up 2. So that radial button selecting like that will go set up 2. Well, and it'll set up the mirroring automatically for me, as well as a watcher that will go into VPC basically to watch, to be the vote, right? Because you can't have a split brain type problem. So we're going to have another piece that watches it to see who's available, that gets to say, oh, that guy's down. The two of us say, you're up. Let's switch over to you. Do we want a public accessible? This is just network stuff we're setting here. And then here's where we would select if we want to do SQL Server authentication. And basically, we have to join an Active Directory that's managed by us. If you don't have one, you can go create one from here. And then I can select the port. We're going to take the standard of 1433. There's the encryption that's built into SQL Server, so I could have my SQL database encrypted at rest by choosing the enable encryption. I'll leave that off. And then how long do I want to retain my backups? So we'll be doing backups automatically, and we can select our retention time. I'll put 17 days for the fun of it. And then the monitoring aspect. Do we want to say don't do patching, don't do minor upgrades, because I'm worried about that changing the way my app works, or I can enable minor updates. So I'm going to leave minor updates enabled, and then I hit launch DB instance. So in about 4 minutes now, I'll have 2 database servers set up that are syncing. I'll have the load balancer in front of it, and it will be that multi-AZ deployment, high availability, no data loss environment set up for me. If I want to go into there, I could then add more databases to it and have 4 or 5 databases, that kind of thing. I can add up. But that is my environment. Now, I've had people ask, okay, so now that that's up, now what? How do I access it? How do I use that? I mean, besides my .NET app that I write to go against it, I should have launched this already, but the Microsoft, not the deployment, where is it? SQL Management Studio. Is that it? That's there we go. No, that's not it. There we go. So I bring up Microsoft Management Studio, and we see the one we just created, the DB instance, is still creating on the back over here. I've got 2 up and running. I've got an Enterprise Edition running, and I've got a Standard Edition running here. We'll just connect up to this Standard Edition one. So if we look at this guy, I can come down, I can look at things such as our CPU utilization, our DB connections, how much free storage we have, how much free memory we have, what my IOPS usage are. I can look at my endpoint, which is the address of it that I connect up to, the port that it's using. This one's publicly accessible, so I can access it from here on the internet, just directly accessing it, and get other information about the server itself. So here, if we look, this is DB7, that's the URL to it. I've got my super secret name and password, and I hit connect. And basically, this is Management Studio. I can go expand tables, create users, do everything that you can do to SQL. It's nothing different than regular SQL. Oohs, ahs, huh? Is that cool? Buttery. Buttery? Thank you. I'll get that in when we're done. That's awesome. So basically, that's RDS, right? I mean, we're still creating the others. So let's see if it's still creating. But generally, in just a few minutes, we'll have that complex environment all set up, and then I can access that for developing or whatever. So I know this is probably a room full of developers, so this joke won't go over well. So easy, even a developer can do it. Huh? Thank you. The gentleman mentioned, there goes my rating. So another piece we're going to look at is the AWS Visual Studio Toolkit. And with this Visual Studio Toolkit, it's a nice graphical environment right in Visual Studio that you can use to manage all aspects of the AWS environment. So I can create EC2 instances, I can create virtual networks, S3 buckets, Elastic Beanstalk, which I'll get into more of. These are all, as well as databases and all of this stuff. So I don't have to go into the console and do that stuff like I just showed you. I can do those creations from within Visual Studio. And that may be of more interest to many of you in here. The graphical environment is so useful, even the infrastructure guys would maybe even load Visual Studio just to get access to it. Maybe not, because they might get a rash. Sometimes infrastructure guys have problems with that. But we're going to go over that, and I'll demo that towards the end. First, I would like to go over Elastic Beanstalk. So if we remember that enterprise architecture, we had front-end servers, we had mid-tier servers, then we had database servers in the back. This is a piece that can create and make the scalable front-end servers as well as mid-tier servers for us without having to do any of the work, just like with the RDS databases. So in the .NET world, I can run both .NET Core and full-blown .NET 4.7 and full-blown 2 and apps like that on here. I can run Server 2008 R2, 2012, 2016, and I can do blue-green deployments with URL swapping where I have environments running. We're going to take a look at this first from the web browser, but then later we'll look at it. Everything that I'm showing from the AWS console is all things I can do from inside Visual Studio with the plugin I mentioned, and we will look at that as well. So that's generally, most of the developers like to stay in Visual Studio, and you never really have to leave it once you configure the authentication. So Elastic Beanstalk is our tool for that. Let's go look at that before we go on to the serverless type environment. So we're back into the console here, and if I go to services under compute, I'm going to go to Elastic Beanstalk. Now, in Elastic Beanstalk, these lovely graphical representations are actually representations of full-blown environments that could be either a single server or they could be multiple servers, just like with RDS, for each one of those green boxes. And first, let's step through creating a green box, and then we'll come back and look at these green boxes a little bit. So I'm going to hit Create New Application. I give it a name. Let's call this reInvent 2017. I'll skip the description, hit Next. And then I get to choose, do I want to do the mid-tier worker environment or the front-end web server environment? I'll choose the front-end web server environment. And then I select a platform. Do I want .NET, Windows, IIS, or one of the many other things that run on Linux? And I'm going to choose .NET, IIS. And then I choose my environment type here. Do I want load balancing, auto scaling, where I've got a layer 7 load balancer, then I've got at least 2 servers and 2 AZs, and then as needs happen, load, whether it's CPU or disk load or some other connection load that I set, we're going to scale out and automatically add more servers. I would choose this. If this is a development area or some app that I think is really unimportant and I want to lower my costs, I can choose single instance. So whether it's development or whether it's the app that we don't care if it goes down, I can choose that. So we'll choose this one to be load balancing. I'm losing the ability to talk. Load balancing and auto scaling. Now, I can update code here, and the way my code deployments go when I do it from the console is I take my code that I've compiled, and then I package it all into a zip file, and then I upload that. And so I can choose my own file, I can point to an S3 bucket, or in this case, we're just going to choose the sample application, which is just a zip file that we already put out there for you that really does nothing but shows a web page and says, thanks for loading the app. I also choose my deployment preferences for when I update the code, because I can update more zip files to it as I continue to rev the code. And do I want to do a rolling update? And then if it fails, like I roll the update and then the servers don't start and they get failures. If it's a certain size of failure, let's roll back. I can say do a batch size of 1 or 30% of the servers. And I could do an all-at-once deployment as well. I don't have to do a rolling deployment. I hit next. We've got to have a unique name, so I check that this name isn't used. No one's used this name. And then I hit next. Now, do I want to connect it up to an RDS database? If I do, I can create one right here. We're not going to hook it up to the database right now. We saw how that works. We just went through that. I choose the size of my instance that I want it to run on, how big, and let's do a T2 Micro free tier 1. I choose my key pair so I can log into these servers. And I can set email address, how my updates go, rolling them or do them all at once. And I can change the size of my root volume if I want. Lastly, I can set keys. Do you guys know what keys are for? The environment tags, not keys. So these are free form. I put in whatever I want from the name and value. I can use them for targeting for management. I can use them for billing purposes and saying, run a report on everything that has to do with application equals HR. And so I can use these tags in different ways, and they are very useful. Lastly, it's taking the profile and the service role that I've already created that give it rights. And that's it. Now we have the review, and I hit launch. So that creates my environment that I get to work within. And in this case, right, we are going to be across multiple AZs and giving that high availability, all of that aspect. So if we do lose a data center from a flood or some disaster, it'll just fail over to the other data center. The other thing is, in this environment, if I write my app well, I'm going to use the ability to scale out, right? If I use a global cache, a global cookie type system, my users could hit any one of these servers. And so at the same time, I'm hitting one data center, I can have another user hitting the one in the other data center. And as they scale out, they're scaling out not just across the servers in one data center, they're scaling across the servers in all data centers. So I'm getting scale out at the same time with this. You don't get that in databases, at least not in our Microsoft database environment. But we do get that for our application, which is kind of cool. So while this area creates, we're going to look at those other ones, kind of the Betty Crocker aspect of demos, right? I've got this pre-baked, so while this one goes in the oven, probably take about 4 minutes for that environment to build up. We'll go take a look at these two environments. This is a whole environment here, this test code repo, and then this web application 4 is another whole environment. They're different because I've gone into this environment and said duplicate. So let me go into this environment and tell it to duplicate again, which is I'm here, I can see information about it, I can look at configurations, logs, monitoring. If I hit upload and deploy, I can deploy a new set of code to this, and it will know that that's a new version. But I might want to duplicate that environment, troubleshooting, testing, installing new code. So I can go to Actions, and I can say, clone the environment. So if I hit clone environment, it gives me some name stuff. I'll hit clone, and now we're cloning the environment. So what that means is, now I've got 3 environments here that are these 3 environments are exact clones of each other. So this may consist of, that load balancer, 2 servers, and 2 AZs. So is this one. So is this one. One of the things I can further do in this environment is, I go update the code. Let's say I update the code in the environment 1. I update the code, and I test it. Looks pretty good. I like it. So this is production. This is test. I can go into here, and I can say, let's go swap environment URLs. And so if I swap environment URLs, I can basically take the production one and now put that production URL to the test environment. That test environment now is production, and production becomes basically sitting there doing nothing, and now my users are hitting production, right? What's that? You got to be connected to that same database, and when you switch them, yeah. And so as far as, it's not when you duplicate that, it doesn't duplicate the RDS environment. If I screwed up, right, I can fail back and I can switch my URLs and go back to what was working if this all starts to go to pot. I don't think I've used that term, and I heard that term since my father said it. But anyway, so this is Elastic Beanstalk. It takes care and manages this for us. We'll look at this next later from Visual Studio, but it can be done just from the console there. Kind of cool. All right. The next piece we're going to talk about is the next step or evolution down the line, which is AWS Lambda. And AWS Lambda does have a place for us in the .NET stack. However, there are things we can't do here. So we run this on top of Linux machines. That means that this is .NET Core. It's not running traditional 4.7 apps. And really, you wouldn't take one of your compiled or one of your old apps, your 4.7 apps, a big, huge app, and load it into this. You would really, first off, because it's core, you probably don't have any of those, but you'd build to this environment. This is more for a microservices type environment. But what's really cool about Lambda is it's serverless. And what that means is I have no servers to manage, or you have no servers to manage. It all runs on servers, right? But this gives us no servers. It gives continual scaling, because what happens is, let's say it's hosting up a web page, right? There's a URL link, an endpoint basically, that gets hit by a web browser. That then causes a thread to spin up in our cluster, in our huge farm environment of servers that we have for Lambda, and it spins up a thread and does the work that your code tells it to do, and then returns that web page if you're doing a website. If you're doing an API, it does that type of work. So what if 2 people hit it? Well, it spins up 2 threads. What if 10,000 people hit it? It spins up 10,000 threads. So there's no thread bottleneck. There's no server bottleneck. They may be on the same server. They may be on completely different servers. It's running somewhere in our farm servers that we have for Lambda. But there's never an idle port sitting open on a server. You don't have a server sitting there, that because of some big workload you need to do, you don't have this 4 terabyte of RAM, 128 vCPU server sitting there, waiting for somebody to do something. It's not in the middle of the night underutilized, right? You don't pay for anything when it's not being utilized. So the way it gets paid for is you get charged for every 100 milliseconds of code execution. And if you compare that to what would take to run, say for example, a a website. Let's say we have a website that gets 16,000 hits a day, average 200 milliseconds to respond to those hits and do dynamic page creation. That would take 2 instances to give the multi-AZ, high availability stuff, using 1 year upfront reserved instances to reduce the cost. That's going to cost about $3 a day, $2.97 a day. So that's not a bad environment. But if I go and use it with Lambda, we're looking at about 5 cents a day. So if you look at that price disparity, that's huge. And so especially when we're looking at apps that are low hit apps, the difference in pricing is crazy. If you start looking at things that are hitting the server continually all day, then they get closer to equal. But the articles I've read online where people have done some analysis of this, even then, they weren't sure if you could get a server, that could actually handle that load to if you got them equal. They were still thinking that it was pretty equal in pricing. So I haven't done the analysis on that, but even as you get higher loads, that is something you would take a look at. So for example, I use the example Bitcoin mining. Bitcoin mining is hammering all day long, right? It's unprofitable to do in clouds, is what I understand. But let's say you wanted to do it anyway for the fun of it. That would be an area where it may be better to do an instance. If you're going to hammer that thing at 100% all day long, you're going to have to do the analysis on that pricing. But that's something that may make an instance more appealing. Otherwise, Lambda is amazing for your apps, especially lightly used apps. The ratio of cost is hugely different. Now the other thing, since it doesn't have a server sitting there waiting, right, there's no port sitting there waiting, you certainly could use the API gateway to have a port there. You can use other things. It executes in response to a change. So one use case I've seen is for the news department. Makes a mobile app for someone's phone and says, hey, when you see something, video it and then upload it to our app, and we'll take that and maybe we'll incorporate it in the news. And so what they can do is have an S3 bucket sitting there waiting for these videos to be uploaded. When the video uploads, they watch for the put happens, and then they act on it. They may rasterize that video into different screen sizes, small for phones, which would be a smaller file size, larger for tablets, and even larger for full-size screens. And they could make a thumbnail for it so it's easy to go see what that video is about and when you pick your videos. That kind of stuff can happen in response to a simple post or a put of a file into a bucket. You can have other things happen when you delete out of a bucket or when some other action happens. There's a bunch of different actions and changes in state that can kick off your Lambda function. That is a really neat tool, but it doesn't take your legacy apps, like I said. That is more for, I would use Lambda or I would use an instance to do that. Not Lambda, I'm sorry, Elastic Beanstalk or an instance to do that. So why .NET Core in Lambda? Because it's modular, low memory usage, runs on Linux, easy and quick to spin up these things, open source. It makes a lot of sense for us to use in the Lambda environment. Now the next piece I want to talk about is the CICD pipeline. In the CICD pipeline, right, that's how am I going to manage my code and do all my work? We have source control. Once you put something into source control, you have it build. And then from there, I might want to test against it to make sure it works. I may have automated testing. I may have manual testing. I may have it go through some type of workflow where someone has to say, yes, I approve, go ahead and put it into production. Maybe I don't. Maybe I just automatically have it go in. But this pipeline is something I've heard a lot of customers ask about. And if you're interested in that, we have some really neat tools here and a whole pipeline that can integrate multiple tools, not just ours, into that. And so if we look at some of the tools we would use in our code pipeline, we can use, of course, our Git repository, AWS Code Commit. You can use other Git repositories, such as GitHub. You can use other repositories, some of them Git-enabled and some of them not, like Visual Studio Team System, which is a Git-type repository from Microsoft, or TFS, an on-premises repository for your code. So all of those will work for source code management. You can plug any one of those into there. And then I can go with build. I can use what we have at AWS, which is called code build, or I can use Jenkins, TeamCity, Solano, any third party that I want to build within there. Basically, when we see the change gets updated into your repository, we then go build it. Then from that build, you can run testing. We do not have any testing applications, so it does require a third party if you're looking to do test. And then lastly, after it passes that aspect of the pipeline, it goes into production. We use code deploy to push it into the pipeline, and that can put it into things like Elastic Beanstalk, or it can put it into an instance and create an instance and put it in there. We can use OpsWorks stacks. We can use third parties for that production. So this is kind of cool as well. Let me go up and show a little piece of that. All right. If we go back to the console here, under services, we've got Codestar. So Codestar is basically a multiple pre-built environments that will build out the whole code pipeline for you and plug all these pieces together and make it very easy to set up. So I created one just a little earlier today, but if I create a new project, I get to choose what kind of project. Now there are pre-built templates and we continue to add more. There are only 2 right now for C#. There's a web application or a web service. And I'll choose the web application here, and it's doing .NET Core. This could be certainly used for .NET 4.7 apps as well, the code pipeline. This pre-built template does not use that. Let's call this reInvent 2017. And we're going to use AWS code commit. I could certainly just pick GitHub right here for this one, but I have this, and this will work really quick and simple. Hit next. So basically what I've got in this is I'm going to use code commit. AWS code build is going to do my compile. Then I've got code deploy, and then for monitoring it's using CloudWatch. And this code deploy is going to drop it into a virtual machine, not into Elastic Beanstalk. But that's what it's going to build for me. So if I create the project, I select a key pair, and hit create, and now it's going to build that whole environment for me. It tells me, what do you want to use to edit? One of the things I might want to use to do the work is Visual Studio, right? And so it gives instructions of how to connect that. The first instruction here is, how do I get Visual Studio connected to it? And it's basically, I have to go into the IAM, the Identity and Access Management part, create a key, basically, so I enter that key then into Visual Studio, into the plugin I download. Then basically, so that's the AWS profile I create, and then I basically connect Team Explorer to my my Codestar project and to my code commit area. So I'm using AWS code commit, I'd add it to that. If I was using Visual Studio Team System, I would basically connect it to that, which is already built into the Team Explorer piece. Let's go over to Visual Studio and show some of this. In Team Explorer, I'm already connected up to code commit. If I wanted to add, this is the AWS Explorer and plugin. If I wanted to add this, if it wasn't there already, the quickest way to do that is to go to Tools, Extensions and Updates. And then when you're here, you would search for AWS, and you'd find it. I already installed it, but basically you would do that, you'd hit install, and then it would add that in. It would actually make you reboot Visual Studio or restart Visual Studio. First thing that would pop up is it would be asking you for your access key ID and your secret key. You put those in there, and that gives you your account. If you want to have different accounts that you access, you could have them all listed here, and you could switch between your accounts. And then I have access to the different services, like DB, the RDS database stuff, like your instances. So if we look at, am I in Virginia? I am. We created the RDS instance today, and so if we look at instances, it pops those up here, and my instance that I created for you guys was right up here. Let me, I want to make this bigger. What do we call it? We called it BJL GGG. So here's my instance information. All right, now let's go back to AWS Explorer. Can I put that in my... Changing my screen size kind of threw me off on that here. I wanted to tuck that in the side there, but I don't know if I have enough screen room. But I can access any of these things. Like we created the Elastic Beanstalk. I can go into here, and I can see my Elastic Beanstalk environments. I'm not showing the third one. I wonder if those didn't finish creating yet. But I can create Elastic Beanstalk from here as well. And so let me go into some code here, get rid of that and get rid of this. Do I have code opened? So I have an application here that I have opened, a .NET app. Now there's two ways to go do stuff within here. So I have a index HTML file here. And if I change this, let's call this, let's change it to BJL reinvent. And let's even spell it wrong. That way we know it's not pre-built. All right, so I made those changes. So now if I go to Team Explorer, I can basically push that code. All right, let's close that. Let's do my sync. All right, why am I not seeing that? Thank you. See, I told you I'm not a developer. I owe you. You have to hit save. Not open folder, save. All right, now where do I do my... Thank you. There we go. Now I'm going to enter my commit reason. There's my great commit reason. I'm not going to commit it. I'm going to do a commit and push. Actually, I should go over to show you the site first and show you the change happen. So let's do that, and then we'll do our push. Services. This is actually going to be code commit. Let's go back to Codestar here. I've got this BJL Web App 1, which is what I'm tied to with the code commit there. And I've got my code repository. So if I go into my code repository, we could go look at the index and see that it's not changed. I can also go into my build environment, my deploy environment, my pipeline. But what I really want is from the dashboard, I want to go to the app. And here's the app. So let's go take a look at the app right now, how it looks. So here's the app right now. And now let's go make our code change and do our commit and push. All right, it's pushing. All right, compressing objects. There we go, now we've pushed it. And so if we go back to Codestar here, as we look at this dashboard and pipeline, we can see in the pipeline, we can watch as the things happen and see what portion it hits, and we can watch the code as it fills through, and if it errors anywhere, we can see that piece as well. But what we should see is as soon as it's done, it will change that. Now that's one way to do code. The other way, on the same project, I'm going to push it out a different way, which I could use either, right? I don't have to have code commit set up to do this one. This is purely Elastic Beanstalk. Remember we set up the Elastic Beanstalk environment? Another way to run your code that's even easier is right-clicking on my project and push to AWS Elastic Beanstalk. So if I push to Elastic Beanstalk, all right, here now it's seeing all the Beanstalk things I created. I created 3 of these, as well as the reinvent one, the brand new one we created. So let's go look at the brand new one we created real quick while I push this out. Let's go services, Elastic Beanstalk. All right, this is the one we just created, so let's hit this link in this app. And it's a .NET assembly, so it's the first time it's being hit, so now it does compile and run. And okay, so that's the sample app that we uploaded. Now what I'm going to do is choose that reinvent environment. I'm going to redeploy. I could create a brand new one here and go through all that next finish stuff, but that would take about 5 minutes for that to set up. I'll use the one we created at the beginning, and I'll actually replace that sample code with this code. And I can do debug or release CPU code. I'll do next, and then finish. And so now what it's going to do is it's going to push it out to Elastic Beanstalk. That is one way to do your code, and the quickest, easiest, fastest way to get stuff to run in AWS of your .NET environment. But that's more useful for a single user, right, than if you're working on a code repository. That would be better to use the code pipeline deployment environment that we're showing as well. So let's see this guy refresh if he's out there yet. Not yet. All right, let's go back and see this guy if he updated yet. Oh, not yet. All right, let me go finish the slides. We'll come back. These guys should, as say, go through their push pipeline. They should get back up and running for us before we're out of here. Should only take a few seconds, actually, or for a few more minutes. So Codestar, we just went through the look of how that works, so I'll skip that. I talked about installing the SDK for using inside Visual Studio. There are actually two ways to install it. One is to download it and run an MSI install. That'll install the plugin to Visual Studio as well as the command line tools for the AWS environment. But if you don't want to leave Visual Studio, the way I demoed works just as well, which is using NuGet. And so that's what we saw there. So before I go into the summary, let's make sure that this stuff worked, because we need to have working demos. All right. I'll refresh on this. Huh? Ooh, zaz, that's cool. So what that did, right, is I checked code in to a code repository. It then built the code. We didn't do any tests. It then went through the basically deployment and pushed it out, and it's doing monitoring on it. So that's that update. Now this one was the Elastic Beanstalk one, and we have a completely separate set of code here, right? This is the sample code, and we did a push from Visual Studio, and basically that just packaged it up and pushed it right up into the Elastic Beanstalk environment. In both of these environments, in this environment, we're scaling across multiples. It's taking longer, and so there it worked as well. So that was two ways to deploy. One is using the code pipeline tool, and the other is just to use Elastic Beanstalk. They worked. I didn't even have to sacrifice a chicken this morning. That's awesome. All right. The gods smiled on me today. And you guys aren't smiling. My jokes don't get any better than that, and I don't understand why you're not laughing. In summary, using AWS Visual Studio, especially the Toolkit into the Visual Studio piece, that's really the way to do development inside AWS from C# and .NET. Adding that into your tool set makes it fun and easy to code. You don't need the dev guys, the ops guys anymore, which I'm an ops guy, so I'm not happy about that, but it makes it really simple to go build your environments. And if you think about that, that environment is extremely scalable. That can handle thousands and thousands of users, and by default, it's going to scale up to 4 servers of load to be able to handle multiple users coming in there. So you could even write bad code, and you can just throw hardware at it to fix that. That's an infrastructure joke. So thanks for attending. That's what I had. We have some additional resources to go take a look at this. I hope you thought this was cool and want to go play with it and build some cool apps and put them up on the internet. And we didn't show speeds and feeds of how fun it is to go open a web browser and download stuff, but these servers are extremely well connected and can really handle a load from just a network perspective. So it should be fun to have your apps running up here. Hopefully you like it. Thanks for attending.